Dear authors and invited guests, it's my great pleasure today to welcome each one of you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT and Global Knowledge Research Foundation. Unfortunately, all, all of us are passing through unseen circumstances and very hard situation due to COVID-19 and the dramatic changes that the whole globe faced since almost 1 year or more. However, we will pass through this very soon by the efforts of scientists and researchers. We hope to you and your families a safe time. And thank you again for being part of this conference, even throughout these hard circumstances and challengeable times. Positively, I would love to share with you that this year we have received overwhelming response to our conference. The responses came from 19 countries, and we received 1,150 papers. Among those papers, 350 were accepted to contribute in this conference, and for sure, all of them will be published in the next 4 volumes for the current year. Dears, we are extremely thankful for being part of this conference and for being able to join us through this digital platform again with the whole appreciation of the hard circumstances and challenges that the human system is facing right now. So we wish this conference to be most fruitful in terms of technical knowledge, and we hope that you will enjoy this day and tomorrow as the 2 days conference, and we hope that all sessions will be interactive as much as possible. For now, I would like to take the chance to kick off the session number 1C, and the best thing to start with is to welcome our chair. To be honest, while going through the profile, even it's very summarized in comparison with his great achievements and contribution to the academia and the knowledge, the science in general. But I get impressed that how can how can people build their profile and be a role model to every researcher and scientific. So let me welcome Dr. Pansham Shukla, and I hope that I'm spelling the name correctly. I'm sorry for misspelling. Dr. Pansham Shukla holds a PhD in electrical and electronic engineering from Imperial College London, MPhil in electronic and electrical engineering from the University of Stardia, which is located in Glasgow, in the United Kingdom, ME in electrical computer engineering, and BE in electrical engineering from Sardar Patel University, which is located in India. Dr. Pashma is a senior lecturer in communication technology and mathematics at the School of Computing and Digital Media. He is also a course leader for computer system engineering and robotics and electronics and Internet of Things, which is one of the most recent trends in our field. Dr. Shakla is a vice chair of Research Student Progress Group and PhD degree. The doctor as well is a vice chancellor. He received the vice chancellor award for outstanding contribution on learning and teaching, as well as the Students' Union's Award for as an outstanding member of academic staff. Our chair has supervised a broad range of projects and published paper in signal and image processing, electronic and communication system. In recent years, our chair has been focused on applications of signals and image processing in computing vision, machine learning, robotics, Internet of Things, and cybersecurity. He has organized conferences and has served as a many technical sessions in the chair role, along with reviewing many international conferences and journal papers. Prior to joining London, met in 2007, our chair worked as a research fellow in the Applied Digital Signal Image Processing Research Center, which is one of the leading centers in the University of Central Lancaster. Besides that, he worked as a research associate in communication and signal processing group at Imperial College London as well, while completing his MPhil in Center for Signal and Image Processing at the University of Stirling in Glasgow. Our chair was involved in tutoring postgraduate courses in mathematical signal processing. Also, last information about our chair that he has involved in teaching research in India and UK since 1996. So thank you, Doctor, for being part of this session, and it's our pleasure to have you to have a feedback to our participants. So now, dears, let's move to the presentations, and we will start with the first one. Let me just please share my screen. And welcome Stephanie William from German as a co-author, as a main author in behalf of the co-authors to present his project or paper, mainly titled as GLab German label dataset for power consumption. We are all encouraged to understand what's this topic and what's behind it. So could you please start the presentation, share your screen, and the floor is yours.
I think you should see my screen back on me.
Yeah, we can see it.
Okay.
So
I try to be focused more on my person than on the slides only. Dear ladies and gentlemen, my name is Sebastian Wilhelm. I work at the Deggendorf Institute of Technology in Germany. It is a great pleasure for me to be part of the ICICT already for the second time this year. However, unfortunately, not physically in London at the Hamilton Center this year. In the next few minutes, I would like to present a new power consumption dataset, the German labeled dataset for power consumption, with which we have collected in 20 private households within the scope of our ongoing research project. A dataset that might be especially relevant for those of you who are dealing with disaggregating power consumption data. Short note in advance, my slides are displayed directly behind me on the webcam stream. If you are not using the speaker view, I would ask to activate it now. Numerous investigations are currently conducted on the re-identification of specific appliances from aggregated power consumption data. The purpose for the re-identification of appliances for the most researchers is to give the residents the opportunity to monitor their own knowns. You can say such meters could be encountered in a household in just the same form. For getting the individual consumption of the selected appliances, we used power plugs, which are connected directly to the appliance to be measured. To be more specific, we use devices from the company Allnet, as exemplified on the slide. These devices allow measurements in a resolution of up to 7 Hertz, which can be accessed within the local network interface via an API. When selecting the appliances to be submetered, we particularly focused on the fact that the devices require direct human interaction. Thus, we generally did not consider such devices as freezers. This results from our use case for which we are collecting the data. More on this later. All measured values were stored centrally and structured in a database in our institute. For this purpose, the smart meter data was periodically fetched and stored using the provided REST API. Since the measurements of the power plugs can only be requested in the local network, a single board computer was used in each of the test households for transferring the data to the central database. In this context, some technical challenges had to be overcome, for example, buffering or time synchronization. You can read more about this in the last year's ICICT proceedings. So far about the methodology. Now let's get a little more specific about all data we have in our dataset. In total, we collected data from 20 different houses in Germany. More precisely, all households were in the southeastern part of our free state, Bavaria. This information and other meter information, such as the number of residents in the household or the living space, are first of all part of the dataset. To prevent re-identification of individual households based on metadata, this was key-anonymized. Then, of course, we have the smart meter measurements, which means in concrete terms, the active load consumption per line conductor at each time in a resolution of 1 Hertz. We collected this data between 70 and 272 days, depending on each household. And last but not least, the label data of 10 devices in the household. These are available in a resolution of up to 7 Hertz, depending on the quality of the wireless connection. These were collected on average for 28 days per household. As far as possible, we recorded not only the type of the device, but also the model name and the location in the household. By the way, this altogether produces around 80 gigabytes of raw data. Now, let's talk about the data quality. We used commercial equipment, which was often networked via wireless. Even with our best efforts, we obviously can't provide the quality of data you get from laboratory equipment. For example, we could observe that the data of the smart meter, that there exists some gaps. This can be a few seconds, or in a few cases can even be for some hours. Another problem we noticed is a constant time shift on the smart meter data. Actually, after about 20 samples, the timestamp is reduced by 1 millisecond. Consequently, this means that the real resolution of the data is not 1 Hertz, but about 0.99 Hertz. Generally, this should not cause major problems, but in the later analysis, it is maybe necessary to compensate this time shift. A further issue we observed is the time synchronization. Even if we used MTP synchronization, we could detect a major time shift of the measured values. This offset is approximately 3 seconds. Now, to conclude my presentation, I would like to introduce very briefly our use case for the dataset. We are working in the field of ambient emergency detection within the residence. We want to recognize when there is potentially an emergency situation by observing typical behaviors of the residents and detecting atypical deviations. This should be based on data which are already available in the household. You can say we want to recycle data. In contrast to projects with the goal of energy monitoring, it is especially important to minimize false positives when disaggregating data for emergency detection. Otherwise, emergencies may not be detected until it is too late. In addition, the focus must be on devices with direct human interaction. Therefore, we are currently working on an approach for data disaggregation ourselves, a nil algorithm. To summarize, let's briefly review the most important facts. As part of our work, we created a new labeled power consumption dataset that, in contrast to many related datasets, collects the aggregated load data using a smart meter. This is especially important when trying to develop and evaluate practical approaches to load monitoring. Smart meters will be the standard in many countries, including Germany, and will be installed in almost all households. So it should be worth considering this data source in a priority. In this rather high resolution, our dataset is currently quite unique. and should be able to support future research. If you are doing some work in the field of load monitoring, I would like to invite you to take a look at our dataset as well. Thank you now for your attention, and I'm still available for any further questions. Please feel free to contact me or my co-authors at any time, even after the conference.
So thank you for the great and innovative presentation, and thank you for supporting the smart meter, which actually for me personally is very important thing to save my life. So wish you all the best. And now I'm turning the mic to our chair for questions, comments, and for sure supportive feedback.
Thank you. It's very interesting presentation, very brief to the point. Um, is there any question from the audience in the chat? I can't see anything. No.
No, the
I
audience
read
didn't
no
post
question.
anything, but maybe at a later stage they will just
Okay,
order their ideas and post the questions.
sure. I have just one question for Sebastian. And that question is, in terms of your resolution, you have 1 hertz and 7 hertz you mentioned. So was there any specific criteria to select that resolution?
Oh, it was, first of all, it was a technical issue. Smart meters, there are still no commercial smart meters which offer a resolution more than 1 hertz. And in literature, you say 1 hertz is the minimum you need to be able to do some non-intuitive load monitoring. And so we have the smart meter 1 hertz, and the 7 hertz or up to 7 hertz in the label data is even a technical issue. Our measurement instruments allowed for measuring up to 7 hertz, and we required it. We just required 1 hertz, but if we had the opportunity to get this higher resolution, of course, we used it and published this 7 hertz with the whole data set, because you can downsample it anytime, but upsample it will be more difficult.
Great, thank you.
Okay. So thank you again for our chair and for the presenter for their time, efforts, and contribution to the knowledge. Now we will move to the next presentation, which will be presented by Ronnie Karmer. He's also from Germany. The title of the paper is The Workflow Support of the Automatic Creation and Selection Energy Efficient Task Schedule in DVSFS processor. So most welcome, Ronnie, and the mic is yours.
Thank you for giving me the word. Let me share my presentation.
We are motivated to see it.
Should be able to see it.
Yeah, it's fine.
Thank you. So I will also welcome everyone. Thank you for attending my presentation. As already said, I'm going to present our workflow-based support for automatic creation and selection of energy-efficient task scheduling on dynamic voltage and frequency scaling processors. My name is Ronnie Kramer, and the name of my co-author, my PhD mother, I would say, is Gudrun Ringer. I am from the Faculty of Computer Science at the University of Technology, so I'm a computer scientist, but my heart is also connected with the mechanical engineering. Why I say this, you will hear a bit later. Why doesn't it jump forward? Let's do it this way. A brief schedule of my structure. So I'm working on creating a system which makes the work with multi-criteria decision problems much easier, more user-friendly, accessible to everyone. So, and one example of multi-criteria decision problem is the scheduling of tasks to execution units. So I'm going to schedule a number of n tasks to p execution units, which in my case in the presentation will be processor cores. But in general, these execution cores could be anything. Now, since this is a multi-criteria decision, I have to present what my criteria are. So one criteria is that I want to minimize the execution time, which I will call the make span. which is the time from when a schedule or a sort of task starts until the last task is finished. And also, I'm going to optimize for the power consumption. Furthermore, the idea of my framework is that based on the knowledge gained from the output of the data, the data can be reused to perform further optimizations. And in this case, I want to reduce the idle time of the processor cores to even further reduce the power consumption. So the motivation behind this task is that this affects a large amount of data and also a lot of repetitive work, which can be automatized. So due to the possibility to automatize some things and the amount of data and utility was required to handle this problem. And so I'm going to present the fork of my original framework, which is specialized in this task of task scheduling. So the feature of this fork is that it can automatically create task profiles which are used to estimate runtimes and power consumptions, perform Pareto optimal task scheduling, adjust the processor frequency to reduce the idle times, and therefore reduce the energy consumption. The general framework I've called Schedule Creation and Evaluation Framework, short SEEFX. This framework is expandable because it's based on components. Everything within the system is stateless, meaning at every point you can connect to any of the components, leave in directive, and it will perform the task whichever connected to this directive. The communication itself does based on the on a REST API, but also it's possible to export JSON files and place them somewhere so that the components will read them in a case where it's not possible to have a direct connection due to firewall issues or anything. This whole system is written in Python, but since it's component-based and connected via REST, it's not limited to Python. You can basically use any programming language you want. And in my special case, the whole system does work without any super user access. This is, of course, excluding the frequency control. In this case, we need some kind to control the processor frequency. So, however, as I already said, this is just the fork. The parent system is not limited to the creation of Pareto optimized schedules. Simply by replacing the task schedule component, we can do anything else. And for example, do also parameter optimization and many other parts. How does the workflow look like in this case with the task scheduling? First, we need some base data. This base data I called baseline data, and this starts with the definition of task and machine. So we define some machines where we want to collect data on, and then we define some tasks we want the data for. So, and then the system, once the machines are defined and the tasks are defined, goes ahead and does perform some measurements to estimate the baseline data on how the tasks behave on the given program. With this baseline data, now the system knows how the tasks will behave, and the user can now create a process what they want the information about. So they define what tasks they want to use and what machines they want to use, and also provide the criteria on optimization. Now the system loads all data, creates a lot of schedules, filters out the schedules with have the which are the best in one part, and then furthermore, according to the optimization criteria, goes ahead and selects the one which has the Pareto optimum for the given criteria. So, and based on this schedule, we get now a problem that we might have tasks which run a bit shorter, other tasks run a bit longer. And then we want to equalize the runtime of all the tasks by adjusting the CPU frequency. And thus we can reduce idle time and the power consumption. The real world use case for this was, as I said, I worked for the mechanical engineer, that we have a very large simulation, which has multiple different parts of FEM, particle flow, and Maxwell simulations, which all run at the same time. And they are different programs, but they need to exchange data. Some have their convergence times earlier, some have later, and so we introduce the idle times, which cause the drop of the efficiency. However, my real world use case is hard to present in this case, so I defined a simpler to understand and simpler to reproduce. For me, it's possible to reproduce my work use case, and so that I use the SpecCPU benchmark set, which consists of a lot of benchmark programs with floating point instructions as well as only integer instructions, which have a different execution time as we see over here. This is the measurement for all the CPU frequencies, the machine, an i7 Skylake processor I observed or I based my work on. And over here is the energy consumption. As we all know, there's a certain point, for example, for this is it's over here, where the energy consumption reach a minimum, which is the optimal case for the runtime and frequency. But if you run faster, we need more energy. Well, basic assumption. So now I went ahead and said, okay, I want to save energy, but I still need my results very quickly. So I went ahead and created the schedule with all the tasks you've seen in the task sheet, and said they should run executed with the highest frequency. So the benchmark at the schedule came up with the schedule over here, where we see we have all these large gaps where the processor was idle. So meaning the schedule we did over here was optimized based on the energy consumption, so that we selected the processor which has the lowest energy consumption overall right now, and this got a new task. So, and as I said, this resulted in this huge deviation, since not every task is saying the same heaviness. So, when we adjusted the frequencies, we came to this part where we see the longest part run with 3.4 gigahertz, and the slowest part or the shortest part we could also run with 2.8 gigahertz. So we got a nice equal distribution of the execution time. Since I have estimations for the energy consumption, I got that we can go down from 454 kilojoule to 424 kilojoule, which equals a reduction of 6.44%. Now, I took those generated schedules and executed them in real world. So, as I said over here, I performed this for 3.4 gigahertz, and that got an estimation of 6.44%. And I also performed the execution for the frequency with the highest efficiency, which for my processor was 2.3 gigahertz. And there we see that we get an estimation of minus 0.26%. This is due to the collection of my base data, which had also the cores which were unused idle, so they contain some idle power consumption. And so it's expected that if we run it the whole schedule, that we get a lower measurement. So now I generated those schedules, measured them for the without the adaptation of the frequency, so with the large idle times, and with the adaptation of the frequency, meaning that the idle times are quite close to 0 seconds. Since those measurements also included idle times for the baseline data, it's expected that this is the minimum reduction we can achieve, and this is also shown by the real measurement, where we got up more than 10% of energy reduction. Also for the 2.3 gigahertz version, we got also more than 2% of reduction. Simply, we didn't waste much time with idling. I also performed this with many other processors, but only had enough space to present it for this processor. And every processor behaved the same.
Okay, so sorry for interruption. I know that we are almost there, but we have 1 minute and a half.
Yeah, thank you. I'm aware. So, as you've seen, we were able to achieve, with our framework, we were able to achieve a reduction of more than 10% for our given use case without any loss in execution time. So we didn't need any more time. And this shows that there's a lot of potential. And the more uneven the execution time of all the tasks is, that the higher the reduction of energy consumption can be without a loss of any time. What will be the future work? Actually, I right now have a web GUI, which is not as user-friendly as I hoped. So I'm going to rework it to make it more accessible. Then I want to add some more criteria which are supported, that we can limit by thread, amount of threads which is supported by each task, add support for AMD Ryzen scheduling, which is not as easy right now, and also support advanced task scheduling. My work is right now not publicly available, but once I reworked the GUI, since then it will be my main goal to be user-friendly, it will be available on my GitHub page, and then free to use for everyone under an open source license. So this was my presentation. I want to thank everyone who was listening to me. My work was supported by the project Seaside, which is funded by the German Ministry of Science and Education. And I'm very thankful that I got the money to work on this.
Thank you very much
do this work.
for the informative presentation. Great idea. We all know and agree on that the automation is the future. So your efforts is highly appreciated. Also, the team has a great contribution. Now, please allow me to ask our chair again for his input, contribution, question, or feedback.
Hello, can you hear me?
Yeah, Doctor, we can hear you.
Okay, I thought the slides are there. That's fine. My question to Ronnie is, you mentioned that you want to optimize N processes on P processes. And over the slides, I think you focused more on the power consumption with the frequencies, and it's minimum at 2 gigahertz. How do you actually schedule those N processes on P processes, and some sort of uh, complexity of scheduling this? Have you considered this, or any measurement have you taken?
Since this work was mainly to present the functionality of our framework, we choose an easy to understand scheduling mechanism. We have tried more advanced scheduling mechanism, for example, that we do all the adjustments to the frequency, so that the do all the frequency adjustment and then pick the best schedule after this part, so to really get the highest possible amount of power saving. But we also did more advanced scheduling with some how is it called, with further predictions. But those are not part of the work I've shown, but we did it in the meantime.
Great, thank you. It's very interesting, very complex, and very sort of at the core of your computer science problem. So very impressive.
Thank you.
So thank you again for the great idea and great contribution. Now let's move to our next presentation, which is about another important topic. Now we will present a paper titled as Open on Demand as a Platform for Virtual Learning in Higher Education. And as we know, due to the current circumstances, everyone is moved towards the virtual learning. So please allow me to introduce Robert on behalf of the co-authors. to present his paper. We are all listening, and the, the floor is yours, Robert. Most welcome.
Thank you. Can you hear me?
Yeah, we can hear you clearly.
Okay. Normally, I prefer to do a demo. I was a little bit, I guess, gun shy today on whether or not I would do a demo. Let's see. Are you able to see my screen?
Yeah, we are able to see the screen.
Perfect.
And
Okay. So normally I prefer to do a demo, but really what I'm going to talk about today is Open On Demand as a way to help people learn about computers, HPC, and just computations. And so, just a little bit about Virginia Tech. We're Virginia Tech. I like to say that we're the only school that has these three things. We've assembled the genome and transcriptome of our mascot. We eat our mascot at the football games, and then we sometimes save them in November. For those of you around the United States, that might be a little bit more funny than for others, but it is true that we have those claims to fame. Today, I'm really going to talk about learning and specifically what we do to kind of facilitate learning at Virginia Tech and some other institutions as well. I'm going to give a quick overview of Open On Demand and then talk a little bit about Open On Demand in the classroom and hopefully stick to schedule. So if we think a little bit about a student, so by student, what I'm meaning is the freshmen that come into our universities. Student is also a powerhouse for researchers, so we have to foster these, but really they're this entity that tries just random stuff, and we have to both facilitate that, but we also have to make it possible. And so how do we do this? Well, at Virginia Tech, we're gonna use something called Open On Demand, and I'll show that here in a second. As a teacher myself, I struggle with this kind of every day in every class. So I teach in the statistics department. I teach using R. And usually the first roadblock that I hit with students is platform. So a student will come into our university and they have all types of different computing platforms that they're using. And something as simple as R can oftentimes be a real roadblock for students on their local platform, which turns into an issue for the instructor. And so we spend a lot of time talking about platform issues and maybe less time talking about science and R and other kind of fun stuff. If we expand that to HPC, we kind of have the same thing where we have this super steep learning curve for people that may not be as comfortable at the command line. So the first thing that we ask students in sort of a HPC world to do is SSH to a cluster. That might be something completely foreign to them. Oftentimes we'll have a second factor that has to be applied, and that might not be as easy on at the command line. We don't access software in the same way. We might use a module system, for instance. We might not be able to install software ourselves and other things. Then it comes down to, well, I want to really just use RStudio. How do I do that on an HPC cluster? I'm going to give you the answer up front, and that's going to be Open On Demand. But really, this is what I'm talking about. We have students that come in and they're somewhere on the spectrum. Oftentimes they'll be a beginner in terms of compute, and we want to facilitate their progression from beginner to intermediate and hopefully power user. And we're going to supply tools to facilitate that progression. The tools that we use at Virginia Tech are sort of listed down at the bottom here. We have ColdFront, which is kind of how you get access to our clusters and how you manage your account and that type of thing. Open On Demand, which is the subject of this talk, which is all about use of the clusters and scientific software. XDMod is kind of the next level stuff, which is how do you monitor your use of the clusters so you can start to benefit from some of the architectures that are actually behind the computers. And then, finally, we exit with usage monitoring down at the bottom to kind of see your account and that type of stuff. So, as I stated, usually I like to do this as a demo. Being so far away, I figured that was too risky. Considering our morning, maybe that was wise, I don't know. But basically, on-demand is a browser-based system to access the computing power within HPC clusters. So we're going to give users familiar browser-based tools to do all the things that they'd like to do on their desktop, but they're going to do that on the clusters. And so we're just lowering the entry to use, if you will. What I'm showing here off to the side, we've got a files app which allows them to access their files in sort of a more familiar tree-based view. There's an easy way to get to command line through the browser as well. So we enable the old way to get to clusters as well as some new ways, and we're just really facilitating access. We can show that through just changing how people access the clusters, there's a real difference in how quickly people get up to speed and actually start to use clusters. So in the graph here, I'm showing you for what happens if people just go to our website and they look at, how do I get an account and how do I use the module system, et cetera, et cetera. There's about a 4-day difference in the end of completion of the first job for a user using on-demand versus kind of the traditional SSH-based access. For us, for this talk, if you think about this in terms of a class, what would take me about a full day to get people, not a day, a full lecture, to get people, a whole class of say 20 students into our HPC clusters, so fully two-factored in, and just loading a module to say, get R at the command line, that might take a full lecture. Now with on-demand, that's about 15 minutes for the class. So I'm really moving from talking about cluster access issues to let's start talking about R, and we do it in one lecture. So that's kind of nice. There, open on demand, its sort of sweet spot is traditionally been interactive apps, so GUI type applications. On demand is, as I stated, a web-based way to get access to clusters, and we have the full ability to expose different apps to users. And we do that through basically the Linux user space. And so we have control over what apps access people see based on who they are and what group memberships they have. So for instance, I'm showing you here, I can make a really nice and simple form-based template to get an RStudio session going on our clusters for a specific class that has sort of minimal things the students might need to know. And I'm showing you just a little bit of some of the other apps that we have going there. Once the student clicks kind of go on that last form, everything that you would think of that needs to happen on an HPC cluster happens. So basically a script is created, that script interacts with the cluster scheduler, and eventually a job is started. What on-demand does in addition is now sets up the reverse proxy type stuff to get access to, in this case, RStudio or MATLAB. So the secret sauce here for open on-demand is we're automating some of the things that are necessary to gain access to the clusters. You can see here a couple other examples. Maybe people want to look at TensorBoard, for instance, and we have an app for that. We can go beyond that and basically script jobs as forms. So for instance, here, this one might seem kind of mundane, but bring your own container just submits a job to convert say a Docker container into a Singularity container. So not something super interesting, but it also shouldn't take a lot of mental effort to get this going. So what's interesting here is because this is browser based, what I can do from the command line in Office, and I would in this case, I can also do from, for instance, the pub. Okay, so we have reports of users using Open On Demand, at the bar, We don't condone maybe some of that, but as long as you're computing responsibly, things are probably okay. But what's interesting about that is that what we can do is we can take a workflow and break it up and have some access points that are very inobtrusive to a user's day, that they can basically shuttle data across the pipeline with very minimal interaction, and they interact at the level that they need to for where they are in the pipeline. So in other words, we can simplify pipelines, allow user input, and basically make them more efficient in their work. Sooner or later, people will hopefully outgrow some of these form-based GUI type apps, and they will hopefully like to use something more script-based. That doesn't mean that we don't have a place here. What we've done is we've created some web forms that allow people to edit job scripts via the browser. So again, it's a more familiar layout than using, say, Vim or one of the other command line editors. Those other tools are still there. We're just giving people another mode of access. By doing this, what we hope is that beginner users will start to see the limits of what they're doing and need to use more. And what we're doing is providing tools where they can get more into the cluster as they need to. So kind of the idea of a telescoping interface.
Okay, sorry for interruption, but we still have around 1 minute and a half, or maybe less.
Perfect. To facilitate that even more, what we're doing is we're integrating XDMod. XDMod allows you to analyze your job efficiency. And so again, what we're trying to do is facilitate users' progression from beginner, hopefully to advanced or power user. And so that's XDMod in that case. You can see here what it does is it looks at, how is your job use in terms of core utilization and that type of stuff. Just a first glance at getting our users to start asking questions and hopefully become more proficient. What does success mean for the educator or the student? It's a little bit different depending upon which side of the coin you are. I've listed some of them here. For the student, it's zero setup. For the educator, it means that oftentimes you skip the platform issue stage of a class, which is really nice. We've got lots of successes. You can read the paper and see these in more detail. What's next? What we're doing is basically modernizing the interface for Open On Demand. And this is where I'm going to stop. Questions?
Okay, so thank you for the impressive presentation, idea, and the great efforts which is literally needed, mainly in these hard circumstances, and it talks to the future. So from the audience, there is no questions, so I will move to our chair and ask him for his input, please.
Yes, thank you. Lovely presentation, Robert. We all know during teaching in COVID times is quite challenging, and such platforms, remote learning, is quite useful. At London Met, we also use remote labs for allowing students to access some specialist software, not R or MATLAB, but in our case, it was circuit simulation software, and which made students' life really, really easy because they could just use a simple browser, log on to our machines in the university, and access specialized software. So fantastic. It's a very useful, simple model for students, which will increase the engagement, and in general, it is beneficial to the university. So yeah, I love that.
Thank you.
So thank you, Robert. Thank you, Doctor, for the great input. And now let's proceed to the next presentation, which will also add a value and an input to the great efforts that have been presented since the beginning of this day. Now we will move to another topic, which is not far from the theme and the context. However, it will add another perspective. The next paper will be titled as Access Control in Cyber Physical Spaces Using Virtual Perimeters. The presenter is Mr. Brian Jervis on behalf of the co-authors. So, Mr. Brian, the platform is yours, and we are all listening to your presentation.
Good evening. Thank you very much for that warm welcome. I'm just quickly trying to share my screen, and hopefully it is being shown. Are you able to see my screen?
Yeah, we are able to see it.
Great, then let me start the timer and this party. Okay, so I am Brian Greaves. I am a PhD candidate at the University of Johannesburg, and I'm going to present to you an access control framework that forms a part of my PhD study. So what am I going to do today? I'm going to talk a little bit about access control so that we're all on the same page. I'm then going to contextualize things in the form of a scenario, talk about two topics of virtual perimeters and indoor positioning systems, and then hopefully you will understand where I'm coming from and then integrate that into the framework. So let's get started. So access control for cyber-physical spaces can be considered from two perspectives. There's the cyber perspective, where you have people in the form of subjects who log onto their computers and they access documents. In a physical sense, it's very similar, that someone, a subject, a human, will walk up to a door and want to then get access to a room or a physical location. So in any access control system, you're going to have people who have permission to access the space or the document and people who do not have permission to do that. So in an ideal world, everyone who has the permissions will gain access to their documents. Every person who has the correct key or key card gains access to the room that they want to access, whereas those who do not have permission do not gain access to the documents, thereby maintaining their confidentiality, integrity, and availability. And those people who want to blow up your servers don't get access to your server room. So the big question here is, how does a system know who really is the legitimate person? And this is where the concept of authentication comes in, where a human being will authenticate to a computer using a password, a token, or some kind of biometric. And if you go up to the door, you will swipe your token card, proving its authenticity, and you'll be given access to the space. So this is where access control comes in. Access control assumes that you're a valid user of the system, and then you will form some kind of a request, and the access control system will intercept it, and then a decision has to be made. So in this system of access control, normally a subject will request access to the object, the door, or a document. The policy enforcement point will then stop that from executing until the policy decision point has made a decision. In order to make the correct decision, it needs to know who you are and what kind of permissions you have. So a policy information point will then provide the required information about you as the subject versus the object. Therefore, the policy information point feeds that to the PDP. The PDP then informs the enforcement point whether to allow access or not. Okay, so that's access control enforcement in a nutshell. Something to bear in mind about this, though, is generally it is subject driven, where a user requests access to a file, a person walks up to a door. It is driven by that. So let's introduce a scenario that's completely the reverse of this. So here we have an office space. This office space has walls marking the perimeter, so you can't enter the office unless you enter through the door, and that is where access physically is controlled. Inside the office space, we have John, who is a subject, who works on his laptop. And also of importance, just not yet, we'll talk about it in a little bit, there's some specialized equipment that we need to control access to. So in this scenario, John is going to log into his laptop at some point and he wants to access documents to do his work job. So he authenticates, then requests access to the documents. Access control will then stop that request and determine the validity of the request against a set of rules and permissions. And if all is good and well, which we hope it is, John is a valid user of the system and he has the permissions, he will then get access to the documents. Now that he has the documents, John goes ahead and opens said documents. And in doing so, the document is now displayed on his monitor physically. So the cyber document that was protected through the cyber access control is now being rendered in the physical world. So this is where things get a little bit more interesting, because now Mary's in the office and Mary's close enough to John's monitor that she can actually see what's being displayed on his monitor. But Mary hasn't requested access to the document on John's monitor. She may have access to the space, So what we know about Mary is that she has permission to enter the room because she's already in the space. However, we don't know that she has permission to view the document because normally Mary would need to request access to the document. But because she's snooping over John's shoulder at the document, no access request has been made. So this begs the question, is this a matter of cyber or physical access control? Should the document be protected in the cyber realm on the computer or in the physical space by trying to prevent Mary from viewing it? So let's consider this. It's a problem if Mary is able to view the document because then she circumvents access control. But also she needs to be close enough to physically be able to read it. If she's on the other end of the room, it's not really a problem. It's not a problem if she's far enough away, but also if the document is obscured or if the document is temporarily hidden from the screen. So let's say John minimizes the document and he's on his web browser. Mary can't see it, therefore not a problem. So let's break this down a little bit more. So here's the specialized equipment that Mary is not allowed to use. And the reason is she doesn't have permission to use it. To make this even worse, there's actually no access control or authentication on that device like there was on John's laptop. So if John is not in the office, Mary can effectively just walk up to the equipment and now we have a problem because she can misuse it, she can break it, she can steal from it. However, if she's on the other end of the room and unable to access it physically, not a problem at all. Here's something that is similar that we might all be experiencing with social distancing and COVID-19, that people need to stay far apart from one another. It's good if you're far apart, but if you're close together, it's not good. So this all boils down to a matter of proximity. Is John too close to Mary that they are going to spread the virus? Is Mary too close to the equipment? Is Mary too close to John's laptop upon which the cyber document is being displayed? So this begs the question, is this cyber or is this physical? Well, in actual fact, it's a matter of both. And the reason being is that normally with physical access control, you would want to do perimeter defense. You limit access at the perimeter at the door, but that doesn't tell us what's happening inside the perimeter. So there's no granularity there for us. And this is where virtual perimeters come in. So virtual perimeters are a form of indoor geofence where you can specify a location wherein actions need to be performed. So if Mary or John were to enter the space where the document is visible, then access control can be performed. So if we look at this topologically, we could demarcate an area around John's laptop labeled A or around the specialized equipment and then perform access control as soon as a subject enters into that area. Alternatively, we could demarcate perimeters around people to prevent them from interacting too closely with one another. But the problem with this is this requires positional granularity. Door control doesn't give you this. You merely know if someone is inside the room or not. You don't know what they're doing, you don't know where they are explicitly. And to compound this, people can move around in the office. So 1 minute, Mary is not by John's laptop, the next minute she is. The state of Mary has changed, but that traditional access control has not changed the state of the document. So this is where indoor positioning systems come into play. In previous research, we analyzed indoor positioning systems and we identified these stereo vision-based computer indoor positioning systems to be very useful in mapping 3D spaces like offices because they see the world like human eyes see them, that they produce point clouds and depth maps of a space, and they can give us images as well as depth maps, or in this case, this is a representation of a 3D point cloud of Cartesian coordinates. And just as a side note, these images are not from the paper, they're from the current state of the prototype that is being built on top of this framework. So just so you're aware, they're here for illustration. So ideally what we want to do is we want to be able to compute the proximity between people and objects. So in order for this to work, we have to augment access control. In order to do this, we need to actually get the proximity information from these camera-based systems, feed it into a policy information point so that access control can be computed continuously and then drive the policy enforcement point to do dynamic enforcement. So instead of the subject requesting access to the object, now the camera system tells the access control system when access should be granted or not. That brings us now to the framework. So the framework we've got is rather a large diagram, but to break it down, there's stuff that happens in the physical space. So we have the cameras and some physical enforcement or deterrence, and then a lot of stuff that needs to happen in cyberspace, because that's where all the computing is going to be taking place. So we've got to have some kind of an application that our subjects can interact with that'll allow us to do some kind of cyber enforcement. And then we need something in the system space which is going to be doing all the heavy lifting and computing for us. So that would be our camera. We then augment our policy information point as well as our policy decision point, and then our policy enforcement point, so that there's a flow of information from the camera through the policy information point to the decision point, so that finally enforcement can take place. To further break this down, we have here our policy information point that is going to receive camera images. It needs to do identification of people, association them to their credentials and their permissions, and then track them around. So for this, we use TensorFlow and common objects in context dataset, and then deep sort to do the tracking. So if we were to track people around the space, here's what we'd see. People identified, laptops identified. This is our authentication unit that we'd use for the next step. In order to then do the association and proximity calculations, that's where we start building our prototype. And in this case, someone like here's Mary authenticates at our authenticator, and then we can track them around the space and see their proximity to various objects. And this information is now the important part that needs to get fed into the decision point. The decision point isn't yet implemented. However, the virtual perimeter monitoring portion of this needs to determine if entities are too close to one another via the proximity calculation and some form of a policy. And decision making needs to implement some form of capable access control model. The design behind the framework is that this is a flexible access control system that we could integrate, say, a role-based access control or something businessy to be used in it. And then finally, we have the enforcement point. Again, it is not yet implemented, but it needs to then be able to do enforcement in both the cyber and physical realms. So in cyber enforcement, we need to do something like hide the documents from John's monitor, or physical enforcement like dispatch a guard or sound an alarm when Mary is effectively too close. For greater details about the actual structure of the framework, it's all in the paper if you want to read it. And what we effectively have done is we've integrated the use of these virtual perimeters via these stereo vision-based camera indoor positioning systems to enable us to have the framework for dynamic access control to be enforced. Future work for this is we actually have to build the access control portion of it and then test it rigorously through prototype evaluation and then make the camera-based portions of it a little bit more efficient. So with that, I'm out of time and I open up for any questions.
Thank you for the great presentation, great idea. And most of us have Mary in their lives, so it's needed for every one of us to use this application and implement this idea on corporate and personal level. So thank you very much for the imperative presentation and idea. On the chat, I don't have any question, unfortunately. However, our chair for sure has a great contribution and questions to discuss. So could you please start, Dr. Benjamin?
Yes, very lucid presentation. I thoroughly enjoyed, and it was very pedagogic. You very well defined the access control in a very simpler manner, and then you slowly unfolded the framework, a vision-based approach. Of course, it is quite challenging. Although we have these libraries, computer vision-based libraries, deep learning, still the problems are enormous in terms of the data quality, acquisition of the images and the processing and taking the decision. And it could be something with the vision usually happens false, true, it's false positive, and ethical issues, which are quite challenging, but very, very interesting project to my mind.
Okay.
Thank you very much.
So thank you, and you were lucky to not have any question. Now we will move to the next presentation. We are almost there for today, but I'm pretty sure that no one get bored because all topics are interesting and matching the recent trends in the academia and technology. Now we will move to another topic, which is titled as Evaluating the Performance of Hybrid equanimous, classical, conventional neural network on ICISQ devices. This topic will be presented by Mr. Najam, and we are all looking forward to hear more and understand the concepts and the theme of the paper. So most welcome, and we are all listening to your presentation.
Thank you. Let me just share my screen.
Yeah.
Can you all see my screen?
We can see a colorful slide. Could you please just move the slides?
Okay, give me 1 second.
Yeah, for sure.
Now?
No, we still can't see an image.
Okay.
If you need help, I will write down my email on the chat and send it to me. I will share it from my side.
Share.
I've sent you my email if you wanted me to help you.
Yeah, can you guys see?
Yeah, it's brilliant now.
All right. So my name is Tristan Noggin, and I will be presenting on my research entitled Evaluating the Performance of Hybrid Quantum Classical Convolutional Neural Networks on NISQ Devices. This research was done in collaboration with my supervisor, Dr. Ritesh Ajuda. So let's start with the problem. So in recent years, quantum computing hardware has improved significantly, and this has caused an increase in interest and funding from both academia and the private sector into developing quantum algorithms for use in fields such as chemistry, finance, and machine learning. The main problem is that these algorithms, which work theoretically, are oftentimes still very complex, and in fact too complex to run on current quantum hardware. And the ones that do run are generally not tested against other versions of these algorithms, which are developed independently by other researchers. So we don't know their true real-world performance, which is a lot more difficult or harder to predict than if you run it in, say, a quantum simulator. In this work specifically, we'll be looking at quantum analogs of the convolutional neural network. Some of the previous work that's been done, the first quantum algorithm to adopt or adapt a classical convolutional neural network was developed to solve quantum many-body problems, which are highly complex systems and extremely difficult to solve. The entire network architecture was attempted to run on a quantum computer, but this required far too much resources, and in fact, too much for current quantum computers to handle. The adaptations that followed opted to just outlay the convolution operation to the quantum computer, while the remainder of the network was left on a classical computer. These hybrid approaches proved more efficient and were able to run on current quantum computers. There were two approaches to this quantum convolutional layer, a structured layer and a random layer. The performance of both approaches was reported to be comparable, if not superior, to the performance of classical convolutional layers. This is what we attempted to prove for ourselves in this work. So the purpose of this work was to determine if these quantum convolutional layers do in fact outperform their classical counterparts when trained and tested under similar conditions. So this is a diagram of the network architecture. You can see we have an input, which is the same as you would input to a regular convolutional neural network, so some kind of image. This in a regular convolutional neural network would be passed to a convolution layer. In this diagram, you can see we swapped out the convolution layer for a quantum filter. More details on that are to follow. From there, it goes to a pooling layer. From the pooling layer, it goes to the fully connected layer, and a softmax is taken at the end, and that is our prediction.
Excuse me,
Uh,
Tristan. I can't see the block diagrams. It's just on the first slide.
this one. This one, yeah.
Yeah, the slides are not moving, that's why.
I think
Oh,
we
the
are
slides
just on
aren't
the
moving.
first title slide.
Oh, is it still not moving?
Yeah.
Is it? Have I exited the slideshow? Can you still see it?
Mm, yeah, you can just click on the slide itself, which is 2, 3. It would be more helpful.
Anything?
No, we are still in the main slide, and you are trying to edit, I think, the title in this way. So just please click on the right, in the left side.
Do you see it here now?
No.
Nothing.
Yeah, we are still stucking on the first slide.
Okay, wait, let me stop sharing and try and reshare again.
Yeah, please.
Let's see. Now?
Yes, now still it is a first slide. If possible, can you click in the left side? There is a 1, 2, 3. Can you click on the second number
Yeah, I can has the control.
on the left side?
On the left side, yeah. Oh, yeah.
Yes,
Yeah,
fine,
yeah, this
fine.
will help.
So I think so. Your slideshow is not working. You can click on to the slide by slide
Okay,
in the left
all
side,
right.
right? Yeah.
So let me get back to where I was. So here, this is a diagram of the network. So as you can see, we have an input, which would be some kind of an image. This would then be passed to, in a traditional convolutional neural network, this would be a convolutional layer. This would then be, in this case, we have a quantum filter. This would then be passed to a pooling layer, and from there it would go to a fully connected layer. At the end, we would take a softmax, and that would be our prediction. This quantum filter, we have two different architectures for it. We have a random filter. So in this case, it would be some length of quantum gate operators. So similar to regular circuits where we have OR gates, AND gates, and the like. In quantum circuits, we have similar things. These work on individual qubits or multiple qubits. This is just meant to be a mapping from one coordinate system, I suppose, to another. The structured filter is the same, except we have these interlaced layers of single qubit gates and 2 qubit gates. This goes on for n layers. In the case of this research, it was 4 layers. At the end, for both of them, we take a correlation measurement, and this gets sent to the pooling layer from the previous slide. Now onto our results. As you can see from these results, the blue line being a traditional convolutional neural network, the red line being a structured hybrid quantum classical one, and the green line being a random hybrid quantum classical convolutional neural network. We can see that the classical convolutional neural network outperforms the quantum one in almost every single test that we ran over multiple iterations, even though in the literature it said that the hybrid quantum classical ones were comparable. The reason for this discrepancy we propose is decoherence. So that is noise that is inherent to quantum computers currently. The word NI, or the abbreviation NISQ, stands for noisy intermediate scale quantum devices. So over time, and if your quantum circuit is too long, over time, the noise that you incur increases exponentially, and your results ultimately turn into nonsense. And so the compounded decoherence over time is what has resulted in the quantum computers performing worse than the classical ones. the reason we propose that the literature says something different is because they ran their models within a quantum simulator, and we actually ran ours on actual quantum computers. So what are the contributions for this research? Well, we wanted to analyze how these hybrid quantum classical convolutional neural network fare in terms of accuracy and loss over time. We wanted to analyze the structure of these quantum convolutional layers and determine why a structure layer or a random layer would work better. And yeah, the rest of these brought to more detail within the paper. I would like to open up for any questions that we may have now.
Okay. So thank you for the great presentation, well-organized ideas, and we are sorry for some technicalities. We appreciate that it's not that easy to manage everything online. Uh, for the chat, I have no ideas, but for our chair, I'm pretty sure that he has an input to enrich the work or has a question to ask.
I think in the chat, we have a question from Robert.
Yeah, I've just noticed it. Apologize. Robert is asking you about, can you give an idea of the data set size you worked with and the number of qubits employed?
So the number of qubits, we had 4 qubits. As for the dataset size, I synthesized a data set of about 10,000 images, all 3 by 3.
Okay, thank you for the clarification. So, Robert, is everything clear? Do you have anything that you would like to ask? You can also open your mic if there is a need. Okay, thank you, thank you. You answered Robert's question, and now we will get back to our chair for his input.
Great. So it was a very interesting question, and I agree with Robert, because I think the questions there in terms of information, data size, and the number of qubits, would it relate to what you observed in the actual physical processor? Because you say it creates a bit of a noise and that is affecting the performance. Would this data size affect in certain ways, or the resolution of 3 by 3 would affect?
So the reason I picked 3 by 3 is because that is the simplest image size that I could feasibly do on a quantum computer. If I had tried anything larger, it would have taken far too long to run. And even if it would run, chances are the circuit would have to be much longer. And so the chance of incurring more noise as the circuit went on would be greater. So 3 by 3 was ultimately the simplest image size that I could do for this experiment. I did think about possibly trying to run this in a simulator on something like the handwritten digits or letters, but I simply didn't have enough time, because getting access to a quantum computer and running these kinds of experiments, it takes very, very long.
Yeah, okay. So, yeah, in the chat we have another argument that thinking seems like enough. 3 by 3 is pretty limiting, and I think that the author explained the limitation that he faced due to time and other research limitations. But I'm pretty sure that all notes will be valued, appreciated, and taken in consideration for the future development of the research. So thanks for the contribution. And before moving to the next presenter, can I just double check if there is any question regarding to the current presentation? Okay,
I think that's it, probably.
Yeah, thank you, Doctor. Thank you for our great presenter. And now let's move to the next presentation, which is also presented to us from Korea this time by Mr. Kim, who's trying to be the act on behalf of the co-authors and introduce his interesting research titled as Approach to Function-Based Navigational Information Model from Autonomous Ship Control and Monitor. So most welcome, Mr. Kim, and we are all listening to your presentation with curious to know more about the research question, the idea, and the implementation. Could you please just share your screen and make your mic on? I'm sorry, Mr. Kim, are you with us? We are sorry, but he's trying to connect the audio. We know that it's expected to have some technical limitations, but the great article deserves to wait a little bit. Sorry, I may move to the
Might
next.
be he has some technical issue. Yeah.
Yeah, he has some technical issues trying to connect the audio, but just to save time and make it more fruitful, I will move to the next presentation. I'm very sorry for the short notice for the next author, but I'm pretty sure that they are ready to present their idea. The next author would be Mr. Makato Yuhara. I'm sorry if I'm spelling it incorrectly, on behalf of the co-authors of the paper titled as Validation of Indoor Localization Method by CNN using Rcsi. So, are you ready, Mr., to present your paper?
Okay.
Mr. Yuhara, are you with us? Yeah, perfect.
Can you see the title slide?
Yeah, we can see the screen. Thank you for being ready and for the presentation. We are all listening to your presentation. Thank you.
Thank you for the introduction. So today I'm going to talk about indoor localization methods using Rcsi. Here is an outline of my presentation. First, I will introduce the background and related works. We will discuss the need for an indoor localization system and see how this has been achieved in previous studies. A problem with the existing methods is its difficulties to ensure a high degree of accuracy in location estimation. We propose a method using deep learning to increase the accuracy. I will show you the results of the experiment before concluding that our method does indeed increase the accuracy of indoor localization. Let's begin with the background. Most of us are quite familiar with localization using GPS. They are widely used in smartphone and car navigation systems. You may have noticed though that they don't work as good when indoors or underground because the satellite signals are attenuated by obstacles like building structures. It is clear that we need a better system for indoor localization, and some have already been proposed. These methods make use of wireless LAN access points, which have become common in modern indoor facilities. The idea is to use the signals from access points instead of signals from satellites. Methods of indoor localization using access points can be divided into categories. The first category is methods based on triangulation. This includes methods such as time difference of arrival and angle of arrival. The location of a receiver is estimated by calculating the difference in arrival time or direction of Wi-Fi signals. The second category is method based on received signal strengths from access points. We will be focused on this second method. There is a correlation between the strength of a signal and its distance from its origin. As you can see in the graph, the strength of signal on a receiver measured by its received signal strength indicator is inversely proportional to the square of its distance from the transmitter. This characteristics of Rcsi is useful in localization because, in theory, any location on a two-dimensional space can be identified from the distance between a receiver and at least 3 different access points. A closer look at the graph, however, we will tell you why this method may not work as well as expected. The same amount of difference in Rcsi means a larger difference in distance as the receiver moves further from the access point and less as it moves closer to an access point. This means that localization based on Rcsi is less accurate when the distance between a receiver and access point grows. Furthermore, obstacles such as walls and furniture in an indoor environment means that the relationship between Rcsi and distance, as shown in the graph, is not as simple in reality. This is why Wi-Fi fingerprinting is used to estimate the location of receiver. Instead of calculations based on theoretical equations, actual values of Rcsi are collected to estimate locations. The method has 2 phases. The first phase is offline phase called calibration, which creates a fingerprint database. A fingerprint is defined by Rcsi from each access point at a specific location. The second phase is an online phase called matching. In this phase, a receiver measures the real-time Rcsi for its location and finds the best matching fingerprint from the database to estimate its current location. Unfortunately, Wi-Fi fingerprinting still has a weakness, which is inherent in most methods of localization using Rcsi. Rcsi can fluctuate due to environmental factors such as humans and objects in the indoor environment. Signals may be absorbed, diminished, or even reflected. If the environment of the first phase in which the fingerprint database was created differs from environment of the second phase, where real-time Rcsis are matched, it is difficult to accurately estimate the location of the receiver. Therefore, the purpose of this research was to reduce the impact of Rcsi fluctuations on location estimation. Because that Rcsi attenuates with distance, therefore, while it is data unique to each location, locations which are physically close should have similar data. If data deviates largely from other positionally close data, it is likely to be an outlier. We chose to use deep learning as our method for location estimation because outliers can be processed appropriately. When outliers enter into the network, the network does not proceed to learn from it, thus reducing the impact on location estimation. Defining its method for solving classification and regression problems by stacking networks and optimizing them with gradient descent. In this research, we use Rcsi as training data and weight them to determine their importance in estimation. I will give two explanations of the proposed method. Firstly, I explain the network configuration of the proposed model. For the network, we use CNN, a representative model of deep learning. Adam W is used for the gradient descent method. We selected DLL for the activation function for the nonlinear transmission. The number of training was determined by stopping. In order to investigate the impact of outliers in the dataset, we also created a model using Synchronization loss as objective function. It has highly robustness to outliers. Next, I will explain the evaluation index that evaluates the model. The mean absolute error is the sum of the errors divided by the number of data. The smaller the value, the higher the accuracy. The coefficient of determination is an indicator of how well the explanatory variables explain the object variables. This verifies that the model makes an estimate with difference to the Rcsi. In this section, I will explain about the experience. Firstly, we compared the other models with the proposed model to verify the effectiveness of it. Secondly, we compared each model using another dataset. Firstly, we compared the other method with the proposed model. In the fingerprinting method, the Rcsi should be measured by the wireless devices at the time of estimation. In this case, we assume that 20% of the data is obtained by the wireless devices and 80% is used as a database for estimation. We use the least squares method for matching. The coordinates of the point where the error is minimized are output. In proposed model and machine learning models, 80% of the data are training data and 20% are testing data. The machine learning algorithms to compare are random forest and light DBM. And output is the predicted coordinates computed by each model. This is a description of the dataset used in the experiment. The Rcsi information covers only 50% of the building. In addition, Rcsi is collected only once for each location. This dataset contains 65 features, but we selected 35 features that are relevant to the estimation. This figure shows the result of the experiment. The blue graph on the left shows the mean absolute error, and the red graph on the right shows the coefficient of determination. First, we can see that MAE of the proposed model is lower and the coefficient of determination is higher than other models. Results, we were able to obtain high accuracy while capturing the characteristics of Rcsi. Comparing the two objective functions in the proposed model, we can see that the smooth error loss has less errors than MSE loss. Therefore, it is possible to estimate with high accuracy even when there are outliers in the data. Focus on the fingerprinting method. The MAE is the second lowest after the proposed model, but the coefficient of determination is lowest among all models. Therefore, although the error is the performance of the estimator will be inadequate if there is a lot of Rcsi variability in the data.
Sorry for interruption, but we still have 1 minute and a half.
We compared these models using another datasets. This explains purpose to investigate the variation in accuracy with the number of fingerprints. My experiential specifications are the same as in previous experiment. This is the description of the dataset. The RSSI information covers on entire floor. In addition, the RSSI is collected 50 times for each location. In order to investigate the effect of the number of fingerprints at each location, we experiment with a fingerprint set of 1 for each location. Here are the results of the second experiment. There is a large difference in accuracy depending on the number of fingerprints at each location. Thus, we can see that the number of fingerprinting has significant impact on the estimation. This is a summary of this presentation. Thank you for your attention.
Thank you for the great presentation, great idea, and solid work. So before moving to our chair back, is there any question that anyone would like to raise, either by opening the mic and the camera or by pushing it to the chat box? Anything? All is clear? Okay, so our chair, we will get back to you now and listen to your feedback or any question to the presenter.
Sure. It's a very solid measurement, very good methodology you followed, a proper reference, and then you identified what were the issues with the original fingerprinting method and the weaknesses, and you leverage the problem by using the deep learning methodology, and you compared very well your proposed method with objective measures such as mean absolute error and R square. What I would ask with this is, in terms of the measurement, would you consider MAE much more closer than R square as an objective measure, or would you consider something else? Because you have two objective measure to compare your method or the performance of your method. Any thought about the objective measures?
So to sum up, the doctor is asking about the objective measurement, if there is any thought, any explanation or supportive idea.
I'm sorry, I don't actually know the answer off the top of my head.
Okay,
yeah.
so
That's fine. I think usually probably you followed the measure normally used by the other methods. So other algorithms also test using mean absolute error and R square. So I guess you followed that, I believe.
Thank you. Thank you for advice.
So I think it's a great hint to save yourself from the reviewers of the future reviewers of any future work, and to add more to the research. However, it's very extensive and very, very rich. So dears, we are now almost at the end of our session. It's my pleasure to be with you today, and I hope that everyone got the most benefit of the session, the ideas, and everything that we preferred to share with you today. For the questions, even that they were limited, but the chairs for this session and the other sessions provided a very informative feedback that will help each one of you to add to their research and make it at the level that everyone is expecting from. So now let me just end this session by thanking every one of you and thanking our share. So I sincerely thank the authors for the excellent presentation and contribution in this session, and all of our participants for being part of the International Congress. Your efforts, support, and great presentations make it come true. I hope this session was informative and knowledgeable as well. All presentations would be all the presenters, I'm sorry, would receive their certificates within a couple of business days. So please make sure to check your emails after 2 business days. And for sure, for the publication, we already communicated Springer regarding them. They will be there live within 4 to 6 months. For sure, I can't conclude and end the session without thanking our chair for the great effort, the great contribution, and for the supportive hints and feedback to each one, regardless of the topic and the deep specialty of it. There was a great contribution and a great idea to improve and to make things went extremely better. So thank you for every one of you again. And even though it's digital session, we will have a chance to have a memory. So please turn on your cameras and let's have a virtual picture to stay at your records. And I'm pretty sure that next year we will be all together physically in better circumstances, celebrating the end of the hard circumstances of COVID-19 and having more fruitful papers and more contribution to the academia and the science, as we are always expecting from you. So thanks every one of you. I will count as 1, 2, 3, then I will press the print screen to instead of the camera. 1, 2, 3. We missed you, so I will repeat it. Yeah. So 1, 2. Anyone else want to be? Oh, so everyone remembers at the last moment. So yeah, 1, 2, 3. So thank you very much for being here, and we wish everyone of you have a nice evening or morning, depending on the time zone. We will see you tomorrow for the rest of our conference. And again, we appreciate your time, your contribution. Wish you all the best, and let's meet next year with more contribution again, and hopefully in better circumstances. Take care, stay safe, and all the best. Thank you.
Yeah, yes. Thanks a lot, Feroz, for moderating wonderful sessions. And thanks a lot, Pancham sir, to chairing a session. Thank you, everyone.
Thank you.
Thank
Take care.
you.
Yeah.
Take care. Have a nice evening. Bye-bye.
Bye-bye.
Bye-bye. Thank you.
Nice link. Bye.
Thank you so much.
Thank you. See you tomorrow.
Thank you and goodbye.
Thank you. Bye-bye.
Have a nice day. See you.
Bye-bye.